Hello, my name is Paul Su. Welcome to this screencast of the G1 garbage collector. There's a lot of information already available on G1, but since G1 will become the default collector for JDK9, I'd like to take this opportunity to give a high-level introduction to the collector. Due to time constraints, this will be a very basic overview, but more detailed information is available. A little bit about myself. I've been working with Java and the OpenJDK community for the past 18 years, primarily in the micro-edition space. Currently, I manage the Hotspot garbage collection team here at Oracle. Today, we'll start with a brief introduction to the variety of collectors currently available in Hotspot before we're moving into G1 specifics. These are the collectors currently supported in Hotspot. Serial is intended to address use cases where memory footprint is critical. Parallel should be the optimal choice in most situations where throughput is important. CMS is built with a focus on latency, but is being deprecated beginning in JDK 9, since for most applications, G1 should provide a better overall experience. G1 is intended to deliver a balance between throughput and latency while not suffering from fragmentation. As mentioned, G1 is now the default collector for JDK 9. It was introduced as an experimental flag in 6U14 and became a fully supported collector in 7U4. As stated above, the goal of G1 is to provide a balance between throughput and latency. The default pause target for G1 is set at 200 milliseconds. By adjusting this value, users can tune G1 to provide either lower latency or higher throughput, with a higher value providing higher throughput at the expense of higher overall latency, or a lower value providing lower throughput and lower latency. There are three properties that are needed to allow G1 to collect objects at finer granularities: dividing the heap into smaller regions, knowing which objects are live within these regions, and keeping track of the pointers between these regions. In the serial and parallel collectors, the heap is divided into only 2 or 3 regions. With G1, the heap is divided into multiple smaller regions, usually around 2,000 regions or so. It uses these regions to achieve a finer granularity on how much garbage to collect at each GC pause. Unlike serial and parallel, the marking phase of G1 is done concurrently. This allows G1 to find all live objects without stopping the Java application. Objects can be marked in multiple regions at the same time. In order to move objects from one region to another, you need to know the pointers pointing to those objects. G1 keeps track of the pointers between regions in order to avoid leaving a stale pointer on the heap. G1 can decide to collect a few regions at a time. By doing so, it can limit the number of objects being processed, resulting in lower pauses. Relative to other collectors, G1 has more data on the state of objects in the heap before a collection begins, giving it more control over the length of the pauses. As G1 begins a collection, G1 needs at least one empty region to move live objects into. A set of regions is selected based on heuristics such as the amount of live data, how much of the heap is free, and the pause target. The live objects from the selected regions are moved into the empty region, freeing the memory from the original regions. The heap is now more compact. There have been a number of significant improvements in G1 since JDK 8. There are numerous changes, but 5 significant improvements are string deduplication, class unloading after a concurrent cycle, eager reclamation of humongous objects, adaptive start of a concurrent cycle, and more effective pauses. More detailed information on each of these is available in the release notes and tuning guides for their respective releases. Here are some links for more information on JDK 9. You can download JDK 9 from oracle.com, participate in discussions on the OpenJDK mailing lists, or follow us on Twitter for news and updates.